Hi, in this lecture, I am going to talk more about the modularized programs. When we work on the problem, you will need to look at the problem and try to break down the problem into smaller pieces. Those smaller pieces can be implemented by the function. And the process of breaking down a problem into smaller subproblems is called functional decomposition. You take a big task and break them down into successively smaller tasks. This is a very natural way to plan. For example, I used building a house as an example before. If you're going to build a house, how are you going to break down into subtasks, into smaller tasks? What you need to do, and all of those, other than buying a brand new homes. Um, then you can perform those smaller tasks and working your way up the tree. This is a very natural way to work. Another example is if I say clean the house. What is a plan to clean the house? Well, clean the house will include clean the bathrooms, kitchen, bedroom, family room, etc. So these are the tasks that you will need to do in order to clean the house. Breaking down a problem into smaller pieces is known as modularized function, and we write function to solve problem. Function is the building block of programs. Function solve problem by um, writing a function to solve it like a smaller piece of a problem. In a functional decomposition, you can two way to write um, as a function. Bottom up, you write a function at the bottom level of the tree, work your way back up. This is very easy to test. I use this most of the time. And the top down, you write the skeleton of the function at the top level and stop the function at the lower level. Top down is easier to look at the overall structure of the program, but it'll be harder to test because the pieces is not there. I will use the bottom up as an example. So let's look at a more um, complex program design here. Many web application form have a date field. User can enter the month, day, and year for their birthday date, for example. Write a program to validate that the date field enters a valid date. For example, um, is 5/18/2000, May 18, 2000 a valid date. Is February 29th, 2003 is a valid date. Is November 31st, 2001 is a valid date. You might have told me, I know some of the dates are valid, some of the dates here are not valid, but how would you write the algorithm and then break it down that problem into smaller pieces? So let's do some brainstorming. Spend a couple minutes to understand the problem. So what is a valid date? If you ask yourself, what is a valid date? Well, valid date has valid month value. January 1 for January, 12 for December. Valid dates have a valid date value. For example, February 29 is not valid date because there's no 29 day in February unless it's a leap year. So how many days in each month you need to know, right? And you need to take the leap year into consideration. And valid dates have a valid year value also. Month, day, and year. Those three things have to be valid. So how do you break down the date validation then? Well, what function do you need? And how to test a function? These are what happens when we do programming design. You break the problem down in a smaller piece. So let's look at the overall structure. At the highest level, I have a function called isValidDate. This is another Boolean function that takes month, day, and year as input. It returns true if the month, day, and year form a valid date, false otherwise. And to find the isValidDate, I need to know if the month is valid, how many days in that month. For how many days in that month, I need to know if the leap years or not, and if the year is valid. These three information has to be correct in order for the month, day, year be valid. And this is called a top-down design. As you can see, I go from top, highest level, and design the problem all the way down. You plan by taking a big test and break it down into smaller pieces. And all of these pieces can be implemented using functions. And when you implement that, you will implement from the bottom up. In other words, in this example, I will implement isLeap year first, and then work your way up to each valid month, days in the month, each valid year, and then each valid date. Work your way up. So let's look at the first exercise here. Write a function called isLeap year that accepts one input, year, and return true if the input year is a leap year, otherwise return false. So what is a leap year? Well, leap year is a year that is divisible by 4 but not 100, or it is divisible by 400. You say what? I know leap years is a year that divisible by 4. Well, it really not quite. Um, People tell you that because we are living in the date, the year that the divisible by 4 is a leap year, but in reality, the 400 and the 100 take into consideration. Year 2000 is a leap year not because it's divisible by 4, because it is divisible by 400. If you live long enough to year 2100, you might get disappointed that year 2100 is not a leap year, even though it is divisible by 4. Likewise, year 1900 is not leap year. So let's write a function. Let me go to the repo and call the function called is leap year. That take a one input year, and this is a Boolean function. A year is a leap year if it is divisible by 4 and not 100, or year mod 400 is divisible by 400. And like the Boolean function we did before, we can return this. Expression, whatever this expression, either true or false, and we can test the code. That's the beauty of the function. After I write the function, I can test the code. For example, in 2019 leap year is 2020 leap year, and I mentioned before 2100 is not leap year. So let's try that. So 2019 is not leap year, so return false. 2020 is a leap year. 2100 is not leap year. So that looks pretty good. You should write more test cases to test this. For the time being, I only write test D3 test cases. Okay, so now let's work our way up in that tree there. Write a function called daysInMonth that accepts two input, month and year, and return number of days for the month. If the month is a number where 1 is a January, 12 is a December, and take leap year into consideration. Aha. So now I ask yourself, so if the input is 2, which is February, and 2016, it will return 29 because 2016 is a leap year. If March input 3, March 2015, March has 31 days. So let me ask you, how many days, which month have 30 days, total of 30 days? Which month has 30 days? Which month has 31 days? Which month has 28 or 29 days? And from doing that, we can write, and I'm going to remove this, days in month, the given month and year, we can figure out how many days in a month. So let's taking care of February first. So if month is February, which is 2, then we just wrote the function each leap year. So I can call if leap year, then if the year is a leap year, then number of days is 29 days. Else, it's not leap year. The number of days is 28 days. So that take care of the February. What about which month have 30 days? That's a 4-month have 30 days. So I would look at using else if we just learned earlier. If month is April has 30 days, or month is June has 30 days, or month is September has 30 days, or month is November. These are 30 days. So if it's not February or not April, June, September, or November, then you must have 31 days. So let's return number of days from the calculation here, from this logic. And I just write the days in month, so I can test whether the days in month work. February 2020. Let's see, July 2019. To really test this, you should have like at least 13 test cases for each month plus the leap year as a minimum. But for the time being, I will just write 3 test cases for now. But you should have many test cases to verify every single condition, every single month. That's a 12-month plus a leap year, so you should have at least 13 test cases to cover all 12-month plus a leap year case. So February 2020 had 29 days, July 2019 had 31 days, April 2018 have 28 days. So that look good. So let's move on to the next function. As you can see, I am just writing a small function one at a time and test the function as I go. Write a function called isValidYear that accepts one input, year, and returns true if the input year is a valid year, otherwise return false. Because the program verifies birthday, the valid year if the year is greater than or equal to 1900. So we make a cutoff point. Nobody probably born before 1900 still alive, assuming. So we're gonna have function is valid year, and in this case, as long as you're born after 1900, it's fine. So this is another Boolean function. We return year greater than or equal to 1900. And again, we can test that. Do the boundary case, 1900. Yes, valid year 2017. I see some squiggly line. I did not complete the function. So let's do something maybe before 1890, before 1900. And again, you should have more test cases to test the function. For the time being, I'm just showing a few test cases. 1900 is a valid year. 2017 is a valid year. And 1890, which is less than 1900, is not a valid year. And then let's look at valid month. Write a function called isValidMonth that accepts one input, month, and return true if the month input is valid month, otherwise return false. A month is a number where 1 is a January and 12 is a December. So anything not 1 to 12 is not valid. So let's look at how do we program, and I'm going to delete this here. You should keep all the test cases. I just delete this, so I have space to write code here. Is valid month, and I taking the month, and this is another Boolean function. So we can return month is greater than or equal to 1, and month is less than or equal to 12. If the month is between 1 to 12 inclusive, then it's a valid month. If it's not, then it's not valid month. So again, we can test it. Is valid month. It's 2 valid. Is valid month. How about 13? And let me just do these two test cases. Again, you should test all 12 months, 1 to 12, and anything not outside of 1 to 12, just to be thorough in testing the function. For time being, again, I only testing 2 test cases to show I can write a function and test the function right away without knowing the whole every piece or the other part of the program. So February is a valid month. 13 is not a valid month. So now we implement 4 functions: isLeap year, daysInMonth, isValid year, and isValid month. Now let's look at how do we put this together. Write a function called isValidDate that accepts 3 inputs: month, day, and year, and return true if the month, day, year form a valid date. Otherwise, return false. So how do we do this? Well, a valid date has valid month and valid year. And the number of day, the day that it shows, had to be less than or equal to the days in the month. So let's look at this. Given this idea here, let's look right down is valid date. Given month, day, and year. So if a valid day is if a valid month, given the month, if the month is valid, and the year is valid, let me make this a little bit bigger. Then let's check if the day that you the function parameter day, if it's bigger than equal to 1, because it had to be 1 or larger, and the day is less than equal to the days in month for that month and year. For example, if I say 31, November 31, 2011, November only got 30 days. So this condition will not be will not be met. So I will return true if the day is 1 or higher and the day is less than the number of days for that month, then this is a valid month because you have a valid month and valid year and a valid date. Otherwise, it's not. So we write the isValidDate. Now we can test it valid date and given, say for example, 2/29, 2019 is valid date, say October, the October 28, 2010. I'm gonna just do a few of them. Is, and again, you're gonna need more test cases than what I show here. Is valid date, let's see, let's do July 31st, 2020. So let's run that. So 2/29, 2019 is not a valid date because 2019 is not a leap year. October 28, 2010 is a valid date. July 31st is a valid date. Again, you're going to need a lot more test cases than one show here to test different month, day, year compilation, so that to make you feel the function work as expected. But the idea is I can write a function and test the function independent of the whole program. And then I can, once we have this, I could have, for example, as user like month equal to int input enter month, for example. Enter date and year. Enter year. Now, then I can just call if is valid date given the month, day, and year. Then I can maybe and maybe your program can maybe do something with the input because you have a valid date now. Else, this part of the code is like a main program, and this part of the code could be like a module that you save as a module, so that other people can use it to validate the date, the month, day, year field. So if I run this now, month save June 31st, 2019. It's not a valid date. And because we have run the test to test every function earlier, it makes you confident that when you write your main program, these functions are going to work. And that is the idea behind modularized program. You break the problem down into smaller pieces and working on those. See what the advantage then? Code reuse. I just wrote 5 functions, and these 5 functions can be reused. And I can put those in as a module. Easier to debug. I write one function, I can test the function. If something doesn't work, I know where. And if you were not able to find the error while you're testing it, but the overall program has some problem, it's much easier to pinpoint where the problem is with the function. Again, ease of testing. You just saw me how I test the code. And clean up separation and teamwork. Yeah, this is only like a 5 function. I could have 5 different people work on those. They have the spec, they can write the function, and at the end, we can combine all this into like a module file. And what that means is the working set of a developer is smaller. Everybody has something to do. They have a clear requirement what they need to do. They can do it. As long as they follow the requirement, the function name, parameter like this, everything can glue together at the end. We will talk more about how to do more testing in the next course, but this is the idea, how to write function and test a function as you write.